Hi, and welcome to the second episode of the Braincast, the show where fiction and reality combine. So, up today, we have some excitement. We're again returning to AppleSoft BASIC. This time we're going to cover control flows. So, what does that mean? So, when a program goes along and you branch out, is where you have branching and you have control flows, you have conditional branching. So AppleSoft BASIC supports two types of controls for branching and looping. So you have, both have their place, their respective place in your programs. So let's talk about branching first. So basically, say your program's going along and you want to go somewhere else, or you want to go call a subroutine. Well, in BASIC, there is the GOTO, and there is also a GOSUB. Now, to the computer science purists, these are both horrible sins, especially a GOTO. So they'll look down, this is in part why they look down their nose at BASIC as a language per se, plus the big B standing for beginner. And so we want to learn about these and understand how we can use them more effectively to kind of structure our program. So a GOTO goes immediately to a line number. Doesn't pass go, just goes, boom, no questions asked. And it doesn't know where it came from. Now a GOSUB allows a subroutine, hence GOSUB for subroutine, but it remembers where you came from. So it remembers where it came from and it's written for the main flow of the control flow. So a GOSUB does not take parameters, neither of them take parameters in fact, and they both go to a line number. Actually, technically they take one parameter, that's the line number. But they won't take variables and things like that for internally scoped variables. So what that means is in AppleSoft BASIC, all variables are declared to be global, but it doesn't necessarily mean that you have to treat them that way. So the routines can access any data that's already been defined in the program before it goes. And so part of it is when you want to do your remarks about a subroutine, you may say, utilize this variable as X, Y, and Z. So, So obviously it can modify any variables, and it's best to document what you're going to be doing. And then at the end of a GOSUB is a return statement, and it goes back to where it came from. And it doesn't matter if it's in a line. So in AppleSoft BASIC, you can have multiple statements on a line followed by semicolons. It'll remember in the middle of it, or if it's at the end of the line, it'll just go to the next line. So what about branching with conditions, or just conditionals in general? So in AppleSoft BASIC, there's only the if statement. It has an if, some kind of condition that must be satisfied to be true, called a Boolean condition, and a then statement, and then a bunch of stuff to the end of that line, the end of that statement block, if you will. So the line number, it can have a bunch of statements afterwards. It does not, however, have the capacity for an else. So if you're going to have one state do one thing and another state do another, or otherwise do another, you got to kind of mess with your variables a little bit because, well, we'll find out why. So, enough of me rambling. Let's look at some code of GOTO, GOSUB, and if, then statements, and how we might combine them.
All right, since last time, I've made a bootable disk to have all of our Braincast code on, at least until we fill it up, depending on how complicated we get over time. So, right now, this is the GOTO example. So now we'll be doing everything on diskette instead of the cassette. And if you remember from when we covered the cassette interface, here we have load, but with a file name. When you do a file name, it automatically knows to go load it off of disk, and you see it's very quick. So this is a very simple program to show what GOTO does. So we set X variable to 1, we print it out, we leave a space, we then add 10 to it, and then we jump right back to line 20, which will print it out and which will loop between 20 and 40 continuously. So if we run it, this will run and basically until the X variable is too large for its data type, and then it'll complete with an error. So this particular example of GOTO, it's very trivial, and this will run forever basically until it errors out. Line 50 is never reached. And with the GOTO, it's GOTO space and then a line number, but the line number must exist Otherwise, you get an undefined statement error. So there's no conditionals here, although we can put those around, and we'll do that in another example. But there you go. The go-to statement just jumps straight to that line number, wherever you are. If we had 40, and we said go to 20, and then we said print more stuff, that never gets run. It can never be reached because unlike GOSUB, it cannot return. So there we go. So there's the go-to, and let's look at GOSUB. All right, now we'll look at GOSUB. Now another command here for the DOS realm is catalog. Catalog will display all the things that are on a diskette, all the files. So obviously, this being Braincast number 2, and we're looking at the GOSUB. Obviously, these are named quite easily to understand. So let's just look at the code really quickly. So basically, we have a print statement saying here's where to start. We're about to go to GOSUB. We have GOSUB to line 100. Now 100 will print out some things. We're going to calculate the cosine of 45 degrees. Trigonometric functions in AppleSoft BASIC are in radians, so we have to have a conversion, which is what all that extra stuff is. And then we have a return statement. Return will go right back to where it came from and continue. In this case, go to line 50, print back from GOSUB, and end. So we see, when we run it, it's exactly what we get. 0.707, that's the square root of 2 over 2, is the cosine as well as sine of 45 degrees. So let's look at the code again. So let's go to 40 and GOSUB 100. And similar to what we did when looking at GOTO, we're going to put that right there. Let's verify we did it correctly. Yep, print more stuff. So now what happens? We actually get the more stuff recorded. See, I printed there. Why? That's because GOSUB can return from whence it came, and when it hits the return statement on line 120, it goes right back. Now, also notice on line 60 we have an end statement, which stops execution, which we learned about in the last Braincast. Well, let's say we take it out. What do you think is going to happen? Well, everything's great until we get to the return. Well, the system knows we didn't come from somewhere, so there's nowhere to which to return. So that's why you've got to have the end in line 60 or wherever before line 100, technically before 120. But if you put it inside of there, if we put it at say 115, then the original call will stop and the program will stop running. So let's say, I'll show you what I mean there. Yep, we didn't come back. See, we don't have the extra text. So now we take that away, there's more stuff, and back from GOSUB. So that is a very quick look at the GOSUB command.
All right, that looks good on GOTO and GOSUB, but what about this if statement? How does it work?
Okay, now it's time to take a look at conditionals. In this case, we're talking about the if statement, and then we'll see how to put it all together to do actually conditional branching. So this is a very interesting and short program. We have 3 variables that we define values. Now these are strict integers. That's what the percentage means. So we have A equals 10, B equals 15, and C equals 80. So we have a statement that it's if and then a conditional and then what to do. And we can combine conditionals. We have ands and ors for binary logic. In this case, it's very straightforward. If A is greater than B, then print A is larger than B. On line 30, if B is greater than A, then print B is larger than A. So it's very simplistic. You probably figure out what's going to happen. It definitely B is larger, and that's exactly what prints. So that's a very short look at an if. So let's load up the next one. So the next if, now I've taken the values, and because we want to be able to change them a little more easily, and put them on different lines. So we start with the same values as before. We have the same 2 conditionals, but we have one more. On line 40, we're going to look at A and C and B and C to see if C is larger than both of them. And we have an AND statement in between. So that's our logical operator there. So we run, of course, B is larger than A, and C is larger than both. Now, if I were to make a modification to say C's value and make it 1 and then rerun it, now we don't get the second statement because C is equals 1. Now, if I make C to be A plus B, now that still makes it larger than both since it's adding them together. So, and they're both positive numbers. So there we have, there's a very short example of looking at logical operators. Now, a little bit more complicated. We're going to look at A and B. We're going to do some other things. We're going to do, as you can see, we have more things out at the end. Now on line 30, this is really the case, and it's probably easier to see it in 80 columns. We put a colon and we can put more things out there. The thing is a line, each line can be 255 characters long, and those colons are how you do more things. So here we have an if, we print, so we have the if then, we print, but we also continue on that line. So what the if statement does is it continues that execution. If that if is true, it continues to whatever else left on that line before going to the next one. And so obviously the next one was the same as before, the values were the same as before, and we do more stuff. So if I put a 35 in here and I just said hi on line 35, that's going to run no matter what, especially if I can spell run, because there's no conditional on it. So the conditional is just for that line, because there's no blocking here, there's no else. And if the conditional is true, it continues with the rest of the line, no matter how many statements are there. If it's false, it just goes to the next one. And if it's true, it continues on with the next one, so that's why 35 always runs. Even if we made B very small, so let's say that we made B a minus 10. Now we won't see that statement, but we're still going to see hi. Very good. And so that's just 3 quick examples of the if statement in AppleSoft BASIC.
The if statement allows for comparisons that create conditionals. Now, let's put it all together.
In this final example is when we're going to put all of it together. We have GOTO statements, we have if statements, and we have GOSUB statements. Now the GOSUBs, we're going to utilize the conditionals of an if to do conditional branching. We're not just going to willy-nilly jump to a subroutine. And we're also going to use that same concept to go to statements and show that just because we can jump willy-nilly doesn't necessarily mean we have to. So what this program does is it will display the sine or cosine of 60 degrees. So that's hard-coded in. We have a conversion at the top. In line 15, this is radians, so 2 pi is the same as 360 degrees. So that's why we take 2 times pi divided by 360. We'll multiply that by 60. We'll pass that to the sine or cosine function. We also have a couple other items here that we haven't really covered, and that is the input statement. We have 2 input statements, one asking if you want sine or cosine, and another one asking if you want to run it. Now line 30 here, we look and see if you've entered an S or C. If you have not, then it'll say print saying select either S or C. It will automatically go to line 20 because there's no routine here. It'll just keep going. If so, then on 40 we say, hey, if you did S, we're going to go sub 100. If you did C, we're going to go sub 210. We're then going to ask, because we know we should have an S or a C, so we don't have to check for anything else. We did that in 30. 60, we're going to ask, do you want to do it again? If yes, we're going to jump to line 20 and ask what do you want. And if you don't put a Y, you put anything else technically, and we'll just end the program. Again, we have an end at 80. We have some remark statements in here about subroutines and sines and cosines, and we use different blocks of numbers for the line numbers so that things are separate. So there we have sine and cosine. Let's do sine first. So square root of 3 over 2 is that value. And then if we say yes, and then we do this cosine, we should get about 1/2, which we do. And then I'll put an H here, and it's just going to finish. So here is an example of branched, conditional branching using GOTO and GOSUB. So even with this level of BASIC, and it's very simplistic structure, we can still do structured programming. We don't have functional blocks of we can't declare a function over multiple blocks, but we can declare these subroutines, which is what we have done. Now on lines 100 and line 210, we could easily put the return at the end of that line. And you can do that when you start designing your code. If you know, hey, this is done, I'm not going to make any more changes, and put your code in like that. That's fine. But for this example, that'll work very well. So let's run it again, and let's not put an S or C. Let's say P, yeah, no. 4, no, that's not right. F is not right. So sign, yep, there we go, value. Here, obviously, it doesn't make any difference. Again, it's showing the conditional statements that we see on line 30 is saying, hey, if it's not S and it's not C, then print you need an S or a C and go back to line 20 to ask again. And so we have the input statement with quotes. That's an optional thing. The variable is not. If that was a number, and we put in a string, it would then say ask again. So with the input statement too, is input statement, until you hit enter, it doesn't continue. It's not an instant thing. The get will be a single character. So, but still that string will hold all that value and say, hey, wait a minute, you're not S or C. Even if we started all that mess with a C, or even spelled cosine out, it's not consine, it's still not an S or a C, and there we go, 1/2. At least it's close. It should be 1/2 fully, I do believe. I probably have to carry pi out to more decimal places to make that better. 3.1415, I remember, I think 1459 or something like that. All right, so there we go. There is a combination of all of what we just learned today. It is ifs and gotos and gosubs and conditional usage, and how we can structure a program and utilize and put our routines in one spot and our main code somewhere else, and it calls those routines. And if these were things that were over and over again, we could have other things could call line 100 to GOSUB. If this was a calculation we needed to use all over the place, we could do that too. All right, let's go back to the studio and wrap this episode up.
So thanks for watching Braincast number 2, a review of GOTO GOSUB if statements and conditional branching, and how we can combine them and structure our code in meaningful and logical ways. So yes, even in AppleSoft BASIC of all things, yes, you can write spaghetti code in any language. You can also write nice code in any language. So give the video a thumbs up, please subscribe. Until next time.